Partition walls. Lesson 2. Monolithic and drywall partition walls.
Monolithic partition walls. Mesh partition walls. For of a mesh partition wall of Fe, 5 to 6 steel, reinforcing mesh with a grid spacing of about 40 by 40 centimeters, we fix a Fe 1.5 millimeters mesh with a grid spacing of 2 by 2 centimeters. If we want to create a self-supporting partition wall, i.e. one that does not load the slab, we would fix the steel mesh to the adjoining load-bearing walls or columns using inclined rebars. Behind the supporting layer, a single-sided formwork is built with a 5-10 centimeter thick layer of gypsum or cement plaster applied to it by hand or machine. Gypsum plaster is a mixture of gypsum, lime, sand and adhesive, while cement plaster is a mixture of cement, sand and slag. After smoothing the surface, the formwork is removed and you have your partition wall. Monolithic reinforced concrete partition walls. A partition wall can also be made of monolithic reinforced concrete with a typical wall thickness of 6 to 12 centimeters. These are heavy structures and therefore require slab reinforcement in the form of beams or ribs. They are challenging to chisel for wires and are extremely difficult to construct, so they are rarely used. Monolithic reinforced concrete partition walls can be constructed with single or double-sided mesh, or mesh placed along the axis of the partition wall. The construction method is the same as for load-bearing walls. After fixing the individually sized mesh reinforcement with pins, we make a double-sided formwork by leaving out the necessary openings and pouring the reinforced concrete wall in one step. When the formwork is dismantled, the wall is ready to be surface treated and covered. Drywall partition walls. Drywall partition walls are multi-layered structures consisting of a frame, insulation and gypsum boards. They are constructed with dry construction technology. Such walls have a high degree of flexibility because they are quick to build and easy to demolish. This is useful if there is need for a change of function. Another advantage is that, due to their low dead weight, they do not require slab reinforcement in the form of beams or ribs. The space between the studs allows for the installation of tailor-made thermal and acoustic insulation, typically in the form of fibre thermal insulation. The structure's thickness can be increased as desired to meet special requirements, including fire resistance, with the right design. The panels mounted on the stud wall, mostly gypsum board, can be placed with great precision. These drywall partition walls do not need to be plastered, but can be painted immediately after applying wall putty. Timber frame structure. Today, the more traditional approach to drywall partition walls uses wooden studs for the frame, typically with a 30-50 mm profile. Plywood is an alternative to using planed timber. The horizontal plates are typically larger cross-section beams, for example 50 by 50 mm, between which the vertical studs are placed, screwed or nailed. The spacing of vertical studs is commonly 50 to 60 centimeters from center. This regular pattern can be broken by the additional studs of the necessary openings, above which a horizontal header is built in as a lintel. Mineral fiber wool, glass wool or rock wool is placed between the studs to provide thermal and acoustic insulation between adjacent rooms. Then, after cutting the individual boards to the required size, screw the gypsum board or plywood onto the stud wall. Putty can be used for the board joints, screw heads and other irregularities to form an even, flat surface to prepare it for painting. Metal stud framing. The more modern drywall solution uses specially profiled metal studs, U-tracks as horizontal elements and C-studs as vertical elements. Typical dimensions of the U-tracks: 50, 75 and 100 mm widths, which can accommodate C-studs placed perpendicular to them, with slightly smaller corresponding widths of 48.8, 73.8 and 93.8 mm. In this example, we use these elements to build a double metal-framed plasterboard wall with increased sound insulation and fire protection. Implementation is as follows. 1. Construct the metal stud framing partition wall after plastering is completed. We start building the stud framing directly on the screed. 2. During the setting out process, we mark the lines of the walls on the structure, the position of the openings and the connections. 3. First, a self-adhesive sealing and separating tape is put where the elements of the frames will be. 4. We place the first stud frame, fastening the U-track to the screed and ceiling and the C-studs to the walls, fixed with dowels. 5. We install C-studs between the U-tracks with a maximum spacing of 62.5 centimeters. We use a spirit level to set the verticality. Next, we attach a single layer of gypsum board to the profiles using self-adhesive strips. The boards are kept 6 to 8 mm from the bottom concrete. The gap is filled with silicone. 7. By repeating points 4 to 6, we construct the second stud framing, closely adjacent to the already installed single layer of gypsum board. The space between the studs is filled with rock wool insulation. 9. At the same time as the infill is placed, the necessary plumbing and electrical wiring for the building services will be installed. 10. Next, the gypsum boards are affixed into place with self-tapping drywall screws. The boards are cut to size so the two layers can be fixed together in a bond while avoiding a continuous horizontal gap running along the wall. This time, the boards are also spaced at the sides by 6 to 8 mm at the bottom and 2 to 3 mm at other places. The gaps are filled with a flexible filler such as silicone. Finally, the surface treatment is applied. The joints and bolt heads are filled with putty applied with a trowel, while reinforcing strips are placed along the joint. Then the perfect flat surface is achieved by sanding. If necessary, the puttying is carried out in several stages.